Hey guys, and welcome to class 3. In class 3, we are discussing section 1.1, which is equations and inequalities is what chapter 1 is, but we're looking at solving for linear equations in one variable. We've actually talked a little bit about this already. If you guys remember, in the first class we started talking about how we solve for x. When I see an equation like, say this, if I have, say, 6, that messed up for a second. If I have, say, 6x minus 4 is equal to 20. So this should look very, very similar to us, as we did talk about this in the first week, that anytime we're trying to solve for x, remember, the idea is to get x by itself. So we want it to say x is equal to some number. So what we have to do is, one at a time, we have to get rid of what's sharing that left side of the equal sign. So here's our equal sign. I mean everything over here, because I want x by itself over here on the left. So I need to get rid of the 6 and the 4. Remember, what we need to do is we need to get rid of the 4 first. We always get rid of whatever's being added or subtracted first, and then we get rid of the number that's being multiplied or divided. So we get rid of that 4. How we get rid of numbers, remember, is we get rid of numbers by doing the opposite of what's currently being done. So because right now 4 is being subtracted, I am going to add 4. The opposite of those two numbers, they are going to cancel one another out, which will help me get rid of that 4. But remember, what we do on one side of the equation, we have to also do on the other in order to keep it equal. So what that means is I am now left with 6x, since we didn't do anything to that just yet, is equal to 24. Now, I need to get rid of that 6. And again, we always want to do the opposite of what's being done. Because 6 is being multiplied, I'm going to get rid of it by dividing. So I'm going to divide by 6, and I'm going to make sure I do that on both sides. That division of that 6 of the same number there is going to help to cancel that out, leaving me with x, exactly what I want. And then on the other side, 24 divided by 6, again, is 4. Remember, just like we talked about in the first class, you can always double check by substituting in your answer. So since this says x is equal to 4, that means I should be able to substitute 4 into right here, into that original problem, and it should come out to be a true statement. And if we do that, 6 times x, well, 6 times 4 is what we're testing here, would be 24, and then minus 4 is definitely 20. So that is true, so that means x must be equal to 4 then. So that is what's called a linear equation. So even though we've seen that already, that's exactly what that is. It's a linear equation where there's only one variable, and we have to solve for that one variable. Solving for, in this example, it was x. X, again, is just typically your most common variable. Now, what we'll see as we continue to move forward in this class or in this section, you will see that there's sometimes a little bit more than just what we had. Instead of just 6x minus 4, instead there might be some more on both sides of the equation, and we have to follow some rules to remember to get it to simplify as far as we can. If you guys are looking in your e-text, there is some information on page 83 that explains when we have a problem, what we have to do is we have to simplify each side of the equation one step at a time. And that's what we're going to do in in these next couple equations. So let me start with one where maybe we only have to simplify one side of the equation. So I'm going to use an example here. If I have 4 is equal to 7 minus 3 times 4x plus 1. Okay. So again, the idea is to solve for x. That's the main thing here. So we need to simplify, and the steps that are on page 83, I'm looking at the middle of page 83 if you guys are looking at that. If you're not, that's okay. I'm doing this right here with you. Where it says solving for a linear equation in one variable, the first step is to simplify both sides of the equation. In that example that we had before, both sides of the equation were already as simplified as they could be. How we can simplify both sides of the equation is, one, if there are any parentheses, we need to remove those parentheses, and we can do so by applying the distributive property, which we also talked about in class 1. 2, we want to make sure that we combine any like terms, as when we have some things that are similar, if they can be combined on that same side of the equal sign, we want to make sure we go ahead and do so before we start moving things to the other side like we did in the previous problem when we were doing the opposite. So let's first simplify that right side. As you can see, the left side of the equation is just 4, so obviously that's as simplified as that's going to get. You can't get any simpler than just one number. But over here on the right side, there's kind of a lot going on here. The first step would be to remove any parentheses that we have. So I'm going to go ahead and do so by applying that distributive property. Since the 3 is there in front of those parentheses, that's what gets distributed. Remember, you want to kind of look at this as -3, and that might help you with this. So let's distribute. So -3 times 4x is going to be -12x. So I'm just going to rewrite what I'm left with here. 4 equals 7 minus 12x, which is, again, we kind of say -12x. And then -3 times +1 is going to be -3. Now we have removed those parentheses, and now I can continue to move forward. Next step would be to combine any like terms. Now again, on the right side, there's nothing to combine because there's only one number. So we're going to leave that, the left side. The left side is fine as it is. But over on the right, we have 3 terms. We have the 7, -12x, and -3. As far as like terms, anything with a variable cannot be combined unless there was something else with a variable also on that same side. But 7 and 3, since those are simply just numbers, we can go ahead and combine those. And again, we're looking at this as if this says +7 and -3, or -3. So how we can simplify that, I'm going to rewrite what we have left. Oops, I meant to switch to the right marker here. So 4 is still over there on the left. 7 minus 3, and combining those two terms right there would make that 4. So then we could either write that as 4 minus 12x, or if you wrote that as -12x plus 4, that would also be okay because it means the same thing. Don't forget, anytime you see subtraction, thinking back to your integers, subtraction is the same thing as plus the opposite, so minus or -12x. So in addition, you could always rearrange those two numbers, and if you had those flipped, that would be just fine too. So that could be written either or. So 4 is equal to 4 minus 12x, or 4 is equal to -12x plus 4. Either way is totally fine. Okay, so now the next thing we need to do is go ahead and sorry, I'm realizing that this is the answer is gonna end up being 0 here, so this is kind of a weird one. So now we have what is left. Now we have what looks very similar to that original equation that we started with, so I'm gonna go ahead and just rewrite what we have left so that you guys can see that a little bit more clearer. So what we have left now, we have 4 is equal to -12x plus 4. So what we have to do is we have to get rid of, again, whatever's on the same side of the x. We want to get rid of the 4 and the 12. We do want to get rid of the 4 first. Since 4 is being added, I'm going to subtract it, and I'm going to do it to both sides. Now is when you start thinking in terms of opposites. When you're starting to move things to the other side or trying to get rid of numbers, that's when you start thinking in terms of opposites, because that will cancel out here. Over on the left side there, 4 minus 4 is 0. So then we're left with 4 is equal to -12x. It's going to still end up being 0 because now to get rid of that -12, since it's being multiplied, I have to divide by -12. That will leave me with x just as I want, but 0 divided by -12 is still 0. So this was kind of a weird example. That was one out of the back of the book, or out of the review section in the back of that section there, section 1.1. Let's do one where we actually come out to have an answer here. So you can see what I mean on how you really just want to simplify each side of the equation as much as you possibly can, even if you have something as simple as this. What if I have 5 times x minus 3 is equal to 20? I have no idea if this is going to work out or not, but let's take a look at it. So again, we want to simplify each side of the equation. So here's the left side, here's the right side. Looks kind of similar to what we've seen before, but we need to clear out any parentheses first. So let's simplify that left side first by applying the distributive property. So that's how we clear out parentheses. So 5, we distribute by taking 5 times x, which we know is 5x, and then 5 times negative 3 is going to be negative 15, or minus 15, is equal to 20. Okay, so that's what we have left, and now you can see this looks quite similar to what we've seen before. So the idea now, each side is already as simplified as possible because of the fact that 5x and 15 cannot be combined, since one is a variable and one is a number. And then over on the right side, we just have the number 20. So each side of our equation is as simplified as it's going to get on its own. Now we start moving across the equal sign by doing the opposite. So we need to get rid of the 15 first, and we do so since 15 is being subtracted. I am going to add it, and that will cancel out that 15 over there on the left. But I make sure I do it on both sides, and that will leave me with 5x is equal to 35. Now I can get rid of that 5. Since 5 is being multiplied by x, I'm going to divide that 5, and once again I will do it to both sides, making sure that we keep it equal. That cancels out on the left and leaves me with x, and then 35 divided by 5 I know is 7. So x is equal to 7. So even if you have one as simple as that is just a matter of applying the distributive property, the only thing that's different to some of these bigger equations is sometimes you just have to do that in multiple places. Let's take a look at another one. Grabbing another example out of your all's text. This one's going to work out a little bit better. But this one is negative 5 times u minus 4 plus 2 is equal to, so here's our equal sign. So there's a lot going on there on the left side, so then there's some more on the right side as well. So this is equal to 11 minus, and then u minus 3. Okay, well let's take a look at this. So what we're going to have to do is, once again, we need to simplify each side of the equation one side at a time. So I'm going to start with the left side over there. We can see there's a lot going on, but right away I can see there's some parentheses. So I'm going to distribute to remove some parentheses here. So we're going to distribute that negative 5. Negative 5 will be multiplied by u and by the negative 4. Negative 5 times u, I know, is just negative 5u. And then negative 5 times negative 4 is positive 20. Remember, a negative times a negative is a positive. And then the plus 2, which is right here, we're just going to drop that down and leave that as is for now. We are going to end up combining like terms over there, but let's go ahead and let's go over to the other side and apply the distributive property over there. Now, what happens over here, and this is one of the biggest things I see, that notice that we have 11 minus and then parentheses. A lot of times people want to distribute that 11 to what's inside the parentheses, but that would not be the case. Instead, there's a subtraction sign right here between the 11 and the parentheses. So that 11 really has nothing to do with these parentheses here. It's not connected in any way. We'll subtract that, but the parentheses, we're not multiplying by that 11. So that's why we don't apply the distributive property with the 11. So since there's not a number in front of the parentheses, you can always use the number 1. It's just assumed, a 1 is assumed to be there because 1 times anything will always be equal to itself. So we can look at that minus the parentheses as if it says minus 1 times that parentheses. It's the same thing how like 5 by itself, if I had 1 times 5, wouldn't that still be 5? Yeah, even though we throw a 1 in it, it doesn't change that answer whatsoever. Oops, I meant to erase. It doesn't change the answer whatsoever, but it now gives us something that we can distribute, and that makes it a little bit easier. So let's go ahead and do that. So anytime you have, there is not a number in front of the parentheses, assume it to be 1. So when we do that, negative 1 times u, so I'm going to go ahead and write the 11 because it's there on its own, but negative 1 times u would just be minus u, or negative u, because 1 times u would just be u. Remember, because 1 times anything is just itself. Whereas then negative 1 times negative 3, negative times a negative is a positive, so that would be positive 3. So keep that in mind when you are distributing. When there's nothing in front of the parentheses, you can distribute a 1 if that makes it a little bit easier to see. Some people don't put that 1 there. If you just look at that as negative, then you can just distribute that negative sign instead. Negative times u would just be negative u, and then negative times negative 3 would be positive 3. If you want to look at it that way, that's totally fine. Okay, so now here's what we're left with. So now we've removed all the parentheses, perfect. The next step is to combine any like terms. So looking at one side at a time, we're combining them one side at a time. We're not moving to another side of the equation, so therefore we're not thinking in terms of opposites just yet. Right now we're just putting some things together. So over on the left side, I have negative 5u, 20, and 2. Since u is a variable, it can only be put together with other u's. It can't be put together with anything else. So I can put together, though, these two numbers. 20 plus 2 would be 22. So simplifying that, I'm going to go ahead and simplify that out. That's just negative 5u. Again, we didn't do anything to that. Plus 22. I just put these two guys together. Okay. Over on the other side, we're going to see something very similar. We're not going to be able to do anything to that negative u, so I'm going to go ahead and leave it on its own and write that first. But we do have a positive 11 and a positive 3, so we can go ahead and put that together as plus, and I'll leave it in green actually, as plus 13, what we have left there. Oh, I can't add. Plus 14, guys. Please excuse me for being ridiculous today. Plus 14. Duh, Ellie. Supposed to be a math teacher here. Okay, so hopefully you guys can see where my mistake was there. Okay, so now we have each side of our equation as simplified as it possibly can. Each side contains both a variable and a number, and then over here you see we have a variable and a number. So now we're going to start trying to cancel some things out. My first step is going to be to actually move our variable to only one side of the equation. See how we have a u on the left and a u on the right? Makes it a lot easier when we only have our variable on one side. So what I'm going to do is I am going to move, and it doesn't matter which side you move it to. I could take this negative 5u and move it over here to the right, or I could take this negative u and move it over here to the left. It doesn't matter. I'm just kind of in a habit of putting everything over to the u over to the variable to the left side. So that's what I'm going to do. So since we have negative u, which can almost be looked at as minus u, I'm going to do the opposite of what's being done right there, and I'm going to go ahead and just add u. So I'm doing the opposite of what is currently there in order to remove it from this side and cancel that out. But remember, we have to do the same thing to both sides of our equation, so I'm also going to do that over here to the left. Since it canceled out on the right, you can see I've done that, I've canceled that out, since they were opposites. But over on the left there, I have negative 5u plus u, which is the same thing as plus 1u. And negative 5 plus 1 would be negative 4. So then we have negative 4u plus 22 is equal to 14. So now we've got our variable on one side of the equation. And you guys will see that even if you did it the other way, so even if you did the opposite of what I did, so just rewriting this right here, just to show you, I'll erase it I just want to show you guys for a second. I told you guys that it wouldn't matter which side of the equation you moved that variable to, as you're still going to end up getting the same answer either way. If you instead decided to say, okay, well, what if I take plus 5u on both sides? That will cancel out over here and leave me with 22 is equal to positive 4u plus 14. You're going to end up getting the same answer in both occasions here, and I'll hang on to that and write that right next to it to show you that you'll get the same answer either way. So let me erase that. What I wrote here. And so it was 22u. All right. So here's what you could have as kind of a side note over here. You could also have 22 is equal to, oh no, yeah, it was 22 is equal to 4u plus 14. I want to show you that it would not matter either way which side you moved that variable to. So just going back to our equation right here, that, now we see it as very similar to what we've seen many, many times before, that the idea is to get u now completely by itself. So what I'm going to do is I'm going to get rid of that 22 first because I want to get rid of whatever's being added or subtracted first. Since it's being added, I'm going to subtract it. So I will subtract 22 from both sides of the equation here. And so subtracting 22 from both sides will cancel it out over here, leaving me still with negative 4u, and then is equal to 14 minus 22 is going to be negative 8. Now, to get u completely by itself, I will have to, since negative u is being multiplied, u is being multiplied by negative 4, I'm going to divide by negative 4 and do that on both sides. Canceling that out over here on the left leaves me with u, and then negative 8 divided by negative 4 is positive 2. And that should be our answer. Going over here to show you guys on this one that it wouldn't, again, like I said, it wouldn't have mattered either way. You should still get the same answer. I'm going to subtract 14 from the side where u is to get u completely by itself and subtract it to both sides. I subtracted it again because 14 was being added. That will leave me with 8 is equal to 4u, and to get u completely by itself we divide by 4 on both sides, and that will mean u is equal to 2. So no matter what, you still get the same answer. It's just, again, as long as you follow that step to get u on one side of the equation, doesn't matter what side it is, as long as you do so, you'll still get the same answer. Okay, so hopefully you guys are seeing what I mean here, that as long as it's just the same thing as we've seen before with those linear equations. That linear equations simply just mean just trying to get our variable by itself on one side. When we do, then, or not, well, I guess I shouldn't say by itself on one side just yet. The idea is to solve for that variable. So no matter how we need to do that, we want to solve for that variable. In order to do so, sometimes we might see that variable on both sides of the equation. So we need to simplify both sides of the equation as best as we possibly can, and that's going to involve moving or getting rid of any parentheses that might be present. So that's going to be using the distributive property. And then making sure that we combine any like terms before we start moving things to the other side of the equation by doing the opposite. I'm going to do one more of these just to hope we feel pretty good with it. And this is the one that's in your text, so I can walk you guys through that one. This is the one that's in the text on page 83. It's the first example that they give of these. So this one says negative 3 times w minus 4 plus 5, so w minus 4 plus 5 is equal to 10 minus, and then here we have parentheses by itself again, plus, so w plus 1. Okay, so once again, the idea is so we're looking at each side of our equal sign. There's our equal sign right there in the middle. So we need to simplify each side of that equal side first before we start doing anything. So let's remove any parentheses that we might see first. So I'm going to distribute that negative 3. So negative 3 times w would be negative 3w. And negative 3 times negative 4 would then be positive 12. That plus 5 that's already there just gets dropped down as we haven't done anything with that yet. And now I want to simplify the other side. And don't forget that 10, with that 10 we are subtracting whatever w plus 1 is. So that 10 does not get distributed. It's actually a 1 that gets distributed. So we can look at this as negative 1 times w. So here we have then 10 just gets dropped down there. Negative 1 times w would just be negative w. And then negative 1 times positive 1 would end up being negative 1. And that's how we would simplify that by using the distributive property. So now we've removed all parentheses, so now we want to go ahead and combine any like terms that we have. So once again, anything with a variable cannot be combined with just numbers, so I can on the left side combine the 12 and the 5. So that means on the left side I'm left with negative 3w plus 17. Over on the other side, I'm not going to do anything with the negative w, so I'll go ahead and write that. And then I have 10 minus 1, and I can combine those, and that would end up being 9. So positive 9, so I'm going to write that as positive 9. I know your book has that as 9 minus w. That is the same thing. 9 minus w is the same thing as negative w plus 9. Remember your rules for integers, that no matter how you wrote that, it's still the exact same thing. So just FYI on that if you guys did do that when you all were working through it. Okay, so just continuing on with what we have here. So once again, that's a 9. I accidentally erased it. Now, since both sides of the equation are as simplified as possible, I want to go ahead and move things to the other side of the equation to get W by itself. So what I recommend for you guys is, just like we did before, go ahead and get W to one side of the equation first before doing anything. So I'm going to go ahead and take, just to show you, that again, you can do it either way. You can move it to either side of the equation. On the last one, I had taken this variable and moved it over here, but this time I'm going to move this -3 and move it over to the right. So kind of doing the same thing. So since it's -3, that's kind of looked at as -3, so the opposite would then be +3. So I'm going to add 3W to both sides. That will cancel it over there on the left, leaving me with just 17. And then over there on the right, -W plus 3W would then be 2W. So 2W plus 9 is what we're left with over there. So now this just looks like the regular linear equations that we're used to seeing. So I am going to go ahead and get W completely by itself by subtracting 9 from both sides of our equation there. That will cancel out those 9's over there on the right side, leaving me with just 2W, and then over on the left, 17 minus 9 is 8. And then so what I have, in order to completely get it by itself, since W is being multiplied by 2, I'm going to divide by 2 on both sides. And that leaves me with W is equal to 4. So that's the idea on those, is I want to just make sure, in order to get my variable completely by itself, I have to simplify both sides of those equations first. And again, then by doing so, I can apply the distributive property if there are parentheses, combine any like terms if there are some similar terms on one side of the equation, and then from there it's just getting our variable to one side of that equation. Okay, so now the next part of section 1.1 is still the same idea. We're still taking a look at linear equations, but what happens if those linear equations include fractions? So this may be something that you want to take a look back into fractions. For those of us that maybe aren't too familiar with fractions, there are some different ways that I'll show you guys how to apply these, but I'm going to show you by using the fraction method first. That's really the best way to approach these, and that's going to help us as we get into next week too. So if you're not familiar with fractions, I'm also going to provide for you guys in the review section a couple tutorials on some fractions, on how to find common denominators, and just some basic understanding of fractions. For those of you guys that are familiar with fractions, you'll be able to move right along in this. But like I said, just for those of you guys that aren't, there should be some review videos there for you to help you out a little bit with those. So here's what happens in these. Anytime you have fractions as part of your linear equation. So giving you guys an example, let's say we have this. Let's say I have 1/4 x minus 3/2 is equal to 2. So here is the best way that we can approach this problem. And some of you guys might be saying, what if I just turn those into decimals? Yes, that totally works in this case. Not always will it work, because sometimes you'll have some repeating fractions, and sometimes you'll have where, and I'm going to show you guys in a couple other examples, you'll have where you've got some other things as the numerator, and that just won't always work. And then, like I said, what we'll do is we get into some rational equations in the next couple classes. Knowing this method will be more beneficial. So what happens is, the way that I can clear out fractions is by using a common denominator. Again, for those of you guys who are familiar with familiar with fractions, common denominator is very similar, or very simple to find, in that we use common denominators oftentimes when we're adding fractions. A common denominator means that I'm looking at my current two denominators, so meaning the 4 and the 2. And I want to find something that they have in common. What I'm going to look for is what's called the least common multiple. Not to be confused with least common factor. Oftentimes people will look at 2 and 4 and say, oh, they have 2 in common. And yes, they do have 2 in common, but that is what's called a factor. That means that both of those can be divided by 2. And I want to find something that they can both go into. And unfortunately, 4 cannot go into 2. So what I mean when I say multiples, for a second I'm just going to draw this down here at the bottom. When I say multiples, I'm thinking of your multiplication tables. So meaning both of our numbers times 1, times 2, times 3, and so on and so forth. Those are multiples of a number. So thinking, like I said, of your times table. So for instance, 4 times 1 would be 4. 4 times 2 would be 8. 4 times 3 would be 12, and so on and so forth. Our multiples of 2 would be 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and we could go on and on forever for both of these. And they will actually have lots and lots of numbers in common. But you guys can see that the very first one that they have in common in terms of multiples would be the number 4. And that is what's called our common denominator. So for a second, you might have to draw out this little chart down here at the bottom to see what that common denominator would be. So for the problem that we're looking at on the screen, our common denominator is 4. How do we use a common denominator to clear out fractions? Simple. If I multiply both sides of this equation by that common denominator, 1, that will help me to, so let me actually write this a little bit better. I meant to use a marker, not a highlighter. If we multiply both sides of the equation by that common denominator, 1, that will help me clear out the fraction. I'm going to show you guys how, but as long as we're doing it to both sides, that will keep it equal. Remember, as long as we do something to one side, we have to do the same thing to the other, and that's why I'm choosing to multiply both the left side of the equation by 4 and the right side of the equation by 4. So the right side is pretty simple. That 2 times 4 I know is 8. That's easy. But over here on the left side, I do have two numbers, or two parts that I'm going to have to multiply. So I'm going to have to distribute. So just showing you guys this. So 4 times 1/4, just rewriting what I have left there, 4 times 1/4 is the same thing as 4 times 1/4 x. That's all. I'm just showing you guys what I've done. The next part would then be, so minus, and then 4 times 3/2, 4 times 3/2, and then is equal to, I'll go ahead and solve that. So all I've done is just show you that distribution. The reason why I'm showing you guys this is because what this allows us to do is, one at a time, I can cancel out those denominators. When I have 4, which is the same thing as 4 over 1, times 1 over 4, those denominators pretty much are those opposite numbers that are the same cancel one another out. They both, that means they're both divisible by 4, and 4 divided by 4 is 1, 4 divided by 4 is 1, and so I'm left with just 1x instead. When those two denominators are the same, that's what happens. They're both divisible by the same thing, so therefore I'm just left with x right there. On the other one, then I have 4 times 3 over 2. 2 and 4 are opposite numerator denominator. Numerator denominator is in terms of these fractions. Those two numbers are both divisible by 2. When I do so, 2 divided by 2 is 1. 4 divided by 2 is 2. So that is essentially what I'm doing, is I'm reducing. I'm looking at two fractions and I'm reducing these two fractions before I multiply them. If you're familiar with fractions at all, again, 4 times 3/2 is what we're doing right here. And 4 is the same thing as 4 over 1. So we have a numerator and a denominator in both of these fractions. And all I'm doing beforehand is just reducing before I multiply. Since opposite numerator denominator are divisible by the same thing, I'm going to go ahead and do so before I multiply these fractions out. And essentially that's what I did in the first one too, except the 4 and the 4 were the same, so they just canceled each other out. That doesn't happen here because 2 and 4 are not the same, but they still can both be divided by 2. It will always be that they can both be divided by that denominator. That will always be the case. So that means I'm able to cancel out that denominator pretty much, and then just think whatever we're multiplying by, so in this case the 4, that just gets divided by whatever that denominator is. So 4 divided by 2 is 2. And what that does now allows me to then just take what I'm left with, which is just, since it's just a 1 at the bottom, I can just ignore it, and I'm just left with 2 times 3, which is 6, is equal to, then now 8. We had already multiplied that. So now the idea is to get x completely by itself, so I'm going to add 6 to both sides of the equation, and x is equal to 14. Now, yes, in this particular question, that would have worked out to where we could have turned these both into decimals. Now, let me show you how you could have done that. It just doesn't always work every single time. In that original equation, you can turn fractions into decimals by taking the numerator and dividing it by the denominator. So if I took 1 divided by 4, then 1 divided by 4 is 0.25. which means 1/4 x is the same thing as 0.25x. If I did the same thing to the 3 over 2 and looked at that as 3 divided by 2, 3 divided by 2 is 1.5. So 3 over 2 is the same thing as, so minus 3/2 is the same thing as minus 1.5 is equal to 2. So now we treat it just like a normal linear equation, since it's not no fractions anymore. I want to go ahead and get x by itself. Since x is being multiplied by 0.25, I'm going to leave that for now, but add 1.5 to get rid of that, to cancel that out, but make sure I do it to both sides of the equation. That will leave me with 0.25x is equal to 3.5. And then to get x completely by itself, I'm going to go ahead and divide both sides of my equation by 0.25. 0.25, and 3.5 divided by 0.25 is 14. So I would still get the exact same thing here. And yes, that is a little bit easier than, especially if we just hate fractions and we can't stand working with those. But that may not always work out the same way. And so I want to make sure that you guys are familiar with how to do that, just in case you do come across something like that. So, and sometimes you might see something, and why those would be, knowing the fractions would be more beneficial too. You can't turn these into decimals, what I'm getting ready to show you. So let's say we have something like, I want to do one that's similar to what you guys have in your text, but it's going to be a little bit more work on these. Okay. So this is the one that's in your text on page 84. So this was going to be a little bit more in terms of steps. So we have n minus 2 over 5 minus m minus 4 over 2 is equal to m plus 5 over 15 plus 2. So this one's a little bit longer. So really important here as to why we're going to use common denominators, because you can't turn m minus 2 over 5 into a fraction. You can't turn m minus 4 over 2 into a fraction. It doesn't work. I'm sorry, into a decimal. You guys know what I meant. Into a decimal. It won't work. So we are going to have to use the common denominator here. So what would happen if we looked at all of our multiples of 15, 5, and 2, the very first one we're going to come in where we're going to see similarities would be the number 30. And a quick way to do that, in case you want to just do this really quickly, look at the multiples of your largest number first. 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45. But maybe take a second to think, okay, now let's look at our other two multiples. Can 5 go into 15? Absolutely. So that would work for that one. But can 2 go into 15? No. So that means, no, we can't use 15. But will 5 go into 30? Yes, 5 will go into 30 6 times. Will 2 go into 30? Yeah, 2 will go into 30 15 times. So therefore, 30 is going to be our common denominator in this case. So that's a quicker way to find that, is look at your largest number first. Okay, so let me go ahead and erase our common denominator chart down here. So we picked 30 as our common denominator. So again, what that means is I can multiply both sides of this equation by that number 30. Doing it to both sides of the equation will keep it equal, because I'm multiplying by 30 on the left and I'm multiplying by 30 on the right. But remember, what this allows me to do is that 30 is going to allow me to cancel out those denominators, because what's going to happen, and I'm going to show you kind of in a larger field, I'm going to go ahead and write all this out, but 5 and 30 are both going to be divisible by 5, so that's going to eliminate the 5. 2 and 30 I can divide by 2, and that will eliminate the 2. 15 and 30 will both be divisible by 15, and that's going to eliminate the 15. That's the idea here, is to cancel out those denominators. So let me write this out one at a time, and you guys may or may not choose to do this, but it helps to see that each part of each side of this equation, so the m minus 2 over 5 is one number, m minus 4 over 2 is another, m plus 5 over 15 is 1, and then 2 is 1. Oftentimes people forget to multiply the 30 by the 2, by that last number by itself, because they don't think it has anything to do with it. But remember, this whole side is being multiplied by that 30. So I'm going to go ahead and distribute and show you how this works, one at a time. So 30 times this whole thing would be 30 times m minus 2 over 5. Okay. Then it's minus this distribution, so 30 times m minus 4 over 2. Okay, so that's how that first side is distributed. Over on the other side, we're doing something very similar. So 30 times this would be 30 times m plus 5 over 15. And then don't forget the 30 times the 2 is our last one, so that's just going to be 30 times 2. So all I've done by showing you that colorful line of equations there is to show you that we want to make sure that 30 is distributed to each part equally on each side of this equation. But here is where we can then cancel out those denominators. Here, at the first part right here, so this is the 30 times m minus 2 over 5. So remember, it's just like a multiplication of fractions here. That what happens is I have opposite numerator denominator with that 30 and the 5, and both of them can be divided by 5. What that does is it pretty much eliminates that 5 because it becomes 1 when I take 5 divided by 5. 30 divided by 5, however, is 6. So remember, the idea is to just divide both of those numbers by the same thing. Both of those can be divided by 5, and that's what that becomes. So now I'm essentially then left with 6 times m minus 2. The 5 had canceled out from the bottom. Doing the same thing over here with the next part, what's in green. 2 and 30 can both be divided by 2, so therefore 2 becomes 1, and then 30 divided by 2 is 15. And so that becomes 15, which means I'm left with 15 times m minus 4. Again, we've removed that denominator then. And then lastly, over on the other side, so now on the other side of our equal sign, since 15 and 30 can both be divided by 15, that makes that 15 1, because 15 divided by 15 is 1, and 30 divided by 15 would be 2, making that 2 times m plus 5. And then lastly, our 30 times 2 we know is 60. Okay, so now what's written in that line of blue there is what we have left. We have now cleared out any fractions, so no more denominators. But now I am left with some distribution, and it comes down to then what we did at the beginning of this section when we were looking at how we need to simplify each side of the equation by applying the distributive property and making sure we then can combine any like terms. So I am going to distribute one at a time here. So 6 times m would be 6m. 6 times negative 2 would be negative 12. Then I'm left with negative 15 times m, which is negative 15m. And then negative 15 times negative 4 would be negative 60. All right. Then on the other side, 2 times m is 2m. And 2 times 5 is 10. And then we still have our plus 60. So now we're going to go ahead and combine any like terms that we have and on each side of the equation. So starting with that left side of the equation first. So just what's right here. I'm combining anything that is similar. Remember, you can combine variables, which means I can combine the 6m minus 15m. 6m minus 15m would actually be negative 9m. And then I can also combine this negative 12 and this negative 60. Negative 12. Oh, I'm so sorry. I just missed that I did that. Guys, what I missed, and you guys may have caught it, negative 15 times negative 4 in that distribution is positive 60. Duh. Sorry, guys. Don't forget, negative times a negative is a positive. So easy to miss those little things, and even I do it sometimes. So always make sure you're going back to double check yourself, as I obviously need to do myself. So I am combining those like terms, though, but it is negative 12 and positive 60, and negative 12 plus positive 60 is positive 48. So that's going to be plus 48 over here on the left. And then over on the other side, we only have one variable, so 2m will remain as is. And I can go ahead and combine my 10 and my 60, and that will leave me with 70. Okay. So now that's what I'm left with. I'm actually going to, because I have a lot of confusing craziness all over the screen here, I'm actually going to erase that and just write what I have left. And hopefully you guys can see that this will look very similar to just what we've seen already so far today. So we are left with what we had at the bottom of that screen, which was negative 9m plus 48 is equal to 2m plus 70. Okay, so now is when we can start, just like we did before, start moving things to the other side of the equation. So I am actually going to get my variable to one side of the equal sign. I'm going to do so by taking this 2 from the right side. I'm going to subtract 2m, which will cancel that there, and subtract 2m from the left, which will leave me within negative 11m plus 48 is equal to 70. Now I want to get m completely by itself. In order to do so, I have to get rid of this 48. So 48 is being added, so I will subtract it. That will leave me with negative 11m over here on the left, since our 48s had canceled. And then 70 minus 48 is equal to 22. Okay. And now I need to get m completely by itself, so m is being multiplied by negative 11, so I am going to divide by negative 11. Dividing by negative 11 would leave me with m over there on the left side, and 22 divided by negative 11 is negative 2. And there's our answer to that one. So that one was kind of a long, complicated one, but you can see what we've done is that what happens when we have that common denominator, the common denominator just makes it to where we can easily eliminate those denominators, because that common denominator, that number that we choose to use, that common multiple I should call it, is also divisible by that denominator. And so each time that denominator will always become 1. So you'll have a couple like that, and you've got a couple examples that I'll show you guys on the review video. In the review video, I think I mentioned that because my class that had this last quarter, I always use I tended to stick with the ones that only could be turned into decimals, as that made that a little bit easier. But then I realized when we got to the next class, so what we're going to do next week, that was kind of hurtful, that it would have been more beneficial for them to know the common denominators. So if I do mention that in that review video, just ignore that. We do want to make sure that we are practicing with the common denominator, and that's going to be helpful on your homework as well. If you guys have any questions at all, feel free to reach out to me. All right, thanks, guys.